We've already talked about compound interest. So I'm going to go through this rather quickly. This is pretty much a repeat, but a quicker repeat, a synopsis, a summary of what we've done earlier, and we'll get you a reference to what we've done earlier. Okay, compound interest, a quick review. Okay, suppose we have a 12% annual interest, and we want to compound it annually. Well, to add 12%, to have 12% interest means we add 12% of whatever we started the year with at the end of the year. So adding 12% is the same as adding 0.12 times our principal, which is the same as multiplying our principal by 1.12. 0.12 being what we add, and 1 being our original principal, which we get to keep. So here's our original principal, here's what we're adding. It's like 1 plus 0.12. 1 times the principal plus 0.12 times the principal. Okay, we do that again once for every year. So in 10 years, how much are you going to have? Well, P of 10, because I'm going to do this in function notation, okay? P is your principal function. P of 10 is your principal function after 10 years. And that's going to be P sub 0, where P sub 0 is your initial principal, multiplied by 1.12. Well, you're going to do that 10 times. You do that every year. If you multiply by 1.12 every year, you have P naught times 1.12. Then you multiply that by 1.12. You multiply that by 1.12. Now you have your principal after 3 years, and you keep that up for 10 years. You'll have multiplied by 1.12 10 times. That's the same as multiplying by 1.12 to the 10th. Okay, so that's what you have after 10 years. And that's real easy to compute with a calculator. It's not too hard to estimate. Okay, and P of t, that's your principal after t years. It's just going to be P naught times 1.12 raised to the t. And we know that this is nothing but an exponential function, and that we can get a graph of this function by taking our graph of the basic exponential function, multiplying it by P naught so that at t equals 0, you have P naught, and your t-axis goes out here. And you have to relabel your t-axis for that 1.12. And we've done this, so I'm not going to do it right now. We'll follow up and do a little bit more of it. Okay? Now, if you have 12% annual interest, that you're compounding it 4 times a year rather than just compounding it annually, then that means that you're going to get 1/4 of your 12%, which is 3%, added to your existing principal 4 times every year. Now this is an advantage because the first 3% just adds to your original principal, but the next 3% is going to add to what you had after adding the 3% to your original principal. And then the next 3% adds to that, and the next 3% adds to that. So after a year, you've been able to put 3% onto 3 higher values, 3 higher principles, and you end up with more money. So you do that 4 times every year. Okay? So you're going to multiply your existing principal by 1.03, because multiplying by 1.03 is the same as adding 3% of your original principal to your original principal. You do that 4 times every year. In 10 years then, you're going to multiply by 1.03 40 times. So your principal after 10 years is what? And you should stop and see if you can write this down. You know, if you're doing this actively as opposed to passively, you're not watching a movie, okay? Stop the video, write down what you think it's going to be. Look back at what I've said, think it through. Well, anyhow, hope you did that. It's going to be P naught times 1.03 to the 40th power. Because in 10 years, you're going to multiply by that 1.03 4 times every year, 40 times in 10 years. In t years, what do you have? See if you can do this one. P of t equals P naught times what? Well, it's going to be times 1.03. But then what power are you going to raise that to in t years? See if you can go through the logic of what I've said here and figure this out before I write it down, which I'm going to do right now. So you haven't paused, do it now. Okay, well, it's going to be 4t. 4 times every year, t years. You're going to do it 4t times. If t is 10, you're going to do it 40 times. Okay, so there we have it. Now, you don't have to do it just 4 times. You might do it just 2 times, but you might do it 12 times, once every month. So you'd add 1% 12 times every year. You can think about what that would be, and you ought to stop and think about what you would get if you added 1% 12 times every year, compounded on what you had the last time you added the 1%. Okay? But we're not going to do that probably. You can think about it. You could compound it every week, 52 times a year. So you get 12 over 52, well, or 12 over 360, 1/30th of a percent, 360 times, because usually when you do annual or daily compounding, you round the 365 down to 360. Okay, well, all that is as it is. Doesn't matter what number of times you do this. If you do it, so we call it n times. N could be 2 compounding twice, 4 compounding 4 times, 12 compounding every month, 360 compounding every day. If you want to compound every minute or every second, you can probably find somebody to do that for you. Okay, you're compounding n times a year. N standing for the number of times you compound every year. Okay, and then you're going to do what? You're going to add. Well, you're going to get 0.12 over n each time, okay? And you're going to add that, well, you're going to multiply by 1 plus the 0.12 over n. Again, the 0.12 over n multiplied by your principal is how much you add. The 1 multiplied by your principal is your principal, which you're adding to, okay? You're going to do this each time. So in t years, you're going to do this n times t times. So what's your P of t? See if you can fill it in. It's going to be an expression very similar to the ones we've already seen. Okay, well, hopefully you've done that, or at least attempted, or at least thought about it. Well, you're going to, every time you compound it, you're going to multiply by this, 1 plus 0.12 over n. And then you got to raise that to some power. What power? Well, in t years, you're compounding n times every year. It's going to be n times t. So that's going to be what you have in general if you compound at interest rate 12% n times per year. There's your principal function. Now, you could ask, well, what if we just compound every instant? Okay, well, you can't really compound every instant, but you can take a limit. As n approaches infinity, what is this approach? Okay, well, if you're going to compound continuously, you're going to have an expression very much like this, except you're going to let n get bigger and bigger. Now, n never gets to infinity, but you can see what the limit as n approaches infinity is. Okay, so you get P naught times the limit as n approaches infinity of your 1 plus 0.12 over n raised to the nt. Okay, in other words, as n goes to infinity, it's the limit as n goes to infinity of compounding n times every year at 12%. Okay, now E is defined to be the limit as n goes to infinity of 1 plus 1 over n to the n. Okay, well, notice the similarity between this and this. With just a little algebra, a little substitution or change of variable, and I'm not going to go through that, you can then prove that this is equal to dot, 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 is equal to P naught times e raised to the RT. Or again, E is this number. E is the limit as n approaches infinity of 1 plus 1 over n raised to the nt. And we've talked about this. I asked you to do some calculations of this. Just a brief review. And this is approximately equal to 2.718. There are more decimals. It's approximately equal to 2.71828. And you can even tack another 1828 on that. And then it keeps going, but not with 1828. It's an irrational number. It's just a weird little coincidence that the 1828 repeats, but then, I mean, it'll repeat because the number goes on forever. It'll repeat again an infinite number of times as far as that goes. It's probably going to be a while. You're only going to get that repeat about once every 10,000 times. Once every 10,000 numbers. We just lucked out here. Got a 1 in 10,000 chance that it repeats. Okay? Nothing mystical about that. Just absolute common chance. Okay. So there we have that. And there we have a formula for compound interest compounded continuously. A couple things here, a little terminology you might see. If you have a periodic growth rate R, your growth factor is 1 plus R. So your periodic growth rate is 0.12, then your growth factor is 1 plus 0.12, 1.12. And P of t would then be P naught times your 1 plus R raised to the t. In this case, if R is 0.12, it's 1.12 raised to the t. Okay? And t is your number of periods. If you have continuous growth rate R, then you get P of t equals P naught e to the RT, as we say here. And also you might want to store it away. It's worth writing down and putting in your notebook. That P naught times e to the RT, just by the laws of exponents, e to the RT can be written as e to the R raised to the t. And I hope everybody is pretty well established on the law of exponents by now, more than halfway through a pre-calculus course. Okay, there we have it.